Good evening, class. Today, this afternoon, what I'm going to do is work through the 1 through 7 on your homework. Remember, our learning target today was I can verify trig identities. I can verify. Remember, verify is just another word for prove. I can verify trigonometric identities. Verify trigonometric identities. We learned a lot about some trigonometric identities today. And remember, here was our list. So let me zoom in on some of them. Remember, you do have a test, a memorization test on the identities on Tuesday. You would need to be able to list all of these identities. We talked about reciprocal identities. That is sine equals 1 over cosecant. Remember, sine and cosecant is related. The reciprocal 1 divided by cosecant. Cosecant is 1 over sine. Cosine is 1 over secant. Secant is 1 over cosine. Tangent is 1 over cotangent. Cotangent is 1 over tangent. Then we talked about quotient identities today. We know that tangent theta is equal to sine over cosine. The reason for this, I'm going to explain this one more time, is we've known that the definition of tangent is y divided by x. Well, in the unit circle, isn't the y value the sine value? So that's why y over x is sine over cosine. And then cotangent is x over y, where your x value is cosine over sine. So these right here, these 8 should be easy. Pythagorean identities. And you need to know what 6 are the reciprocal, what 2 are the quotient, because they involve division. And then Pythagorean identities come from Pythagorean theorem in the unit circle. And I'll remember them like this. Pythagorean theorem has squares in it. These have squares. You should know the first one already. Sine squared plus cosine squared equals 1. We talked about that in workshop. Then you need to know tangent squared plus 1 equals secant squared. Cotangent squared plus 1 equals cosecant squared. Okay? So we worked a lot with these identities today. Now, like I said, our learning target was I can verify trig identities. And verify means prove. Well, remember, when we're verifying, we have 2 goals. The first one works most 90% of the time. And today we already did work with number 1. Tomorrow we'll have an example where we do number 2. But number 1 says transform the more complicated side of the equation into the simpler side. Transforming the more complicated side into the simpler side. You're breaking it down. 2, if that doesn't work, then you just show that both sides of the equation are equal to the same value. If both sides are equal to the same value, that means that the 2 sides are equal. Okay? Now, you said, Mr. Esther, on this first one, if I was transforming what I believe was the more complicated side, but I didn't go nowhere, what would I do? Erase, start over, start on the other side. It might be more complicated. Now, what are some toolkit strategies that we can use to help verify? Well, these are the 5 predominantly ones used. Most of the time, if you express things, remember, sine and your cosine is the most basic ones. If you can express in terms of sine and cosine, you go for it. Then you could use your Pythagorean identities. If you see that squares are involved, then that might be a Pythagorean identity that you can use to help simplify something down. The form method. If you see 2 things in parentheses side by side, form it out and see what you get. Factoring. If they have something in common, you could bring it out. And the last one is find a common denominator. If you're adding 2 fractions with different denominators, you might need to find a common denominator. So those are your strategies that you might be presented with. So what I said is I'm not going over examples today. I'm going over and helping you with your homework tonight to build your confidence, okay? So let's look at, we're on page 3 of your notes, and I'm copying this off your notes, okay? Off your homework. So the first one, you have sine theta over tangent theta equals cosine theta. Okay, that's what I want to prove. Okay, I'm going to try the first one, transforming the more complicated. That to me is more complicated. Cosine is pretty basic. You can't do anything with that. So I'm going to choose this side. So what I'm going to do is come under it and write it to let me know that you're choosing that side to work with. Hey guys, I think about this in my head. Look at my strategies here. There's no fractions involved, so I don't need to use that strategy. There's nothing I can factor out of that. There's nothing in parentheses to fill, and there's no squares, so the only thing I can do is just break it down to sine and cosine. Okay, sine is pretty simple. Can't do anything with that. But I could break tangent down using the quotient identity. Using this identity. So I'm going to rewrite it. I rewrote tangent theta as sine over cosine. That is a complex fraction right there. I know. So what I'm going to do is rewrite it what it really means. I'm going to come under it and write sine theta divided by sine theta over cosine theta. When you're dividing fractions, you multiply by the reciprocal. When multiplying fractions, you can cross simplify. I can cross these out. Now, in my mind, I was trying, how am I going to get to cosine theta? Well, I just did. That's the only thing left. So, at this point, I'm done. Bring what I wanted to prove down here and box it in. You just proved to me by breaking this side down that cosine theta is equal to cosine theta. Let's look at number 2. You can always pause and rewind the video if you need to see it again, okay? Okay, so I look at number 2. There's no adding fractions, so I rule that common denominator out. Okay? And I'm going to tell you, I'm going to try to transform the more complicated side. To me, that is more complicated than that. Sine is basic. I can't do anything with sine x, but I could break that tangent and secant down. So, like I said, there's no common denominator. I can't factor something out of that. There's no parentheses, so there's no formula. Nothing squared, so I can't use my Pythagorean identities. But I go back to that old trusty strategy. Express things in terms of sine and cosine. I can break tangent down using that quotient. I'm going to come under it once again and write this to let me know that's the side I'm going to break down. I can rewrite tangent as sine x over cosine x. See, Mr. over here is a theta and nice x. It does not matter. Remember, x and theta is both variables. It's okay. So I broke the tangent x down as sine x over cosine x divided by, now how can I break secant down? Thinking, okay, how can I get secant? I know it's related to cosine. Well, guys, remember, use your reciprocal identity. Secant theta is equal to 1 over cosine. So I'm going to rewrite that as this divided by 1 over cosine x. So, Mr. Judge, that is one bad fraction. I know. Remember how we came under and rewrote what it meant. That's what we're going to do here. It really means sine x over cosine x divided by 1 over cosine x. Okay, when you divide, remember you multiply by the reciprocal. Flip it. Multiplying fraction. Now, if there's a plus here, I cannot cross simplify, but there's a time, so what I'm going to do is mark this out. Remember, what was I trying to aim for? Sine x. What's the only thing left down here? Sine x. So, sine x, I prove that. Bring this down. And I just prove that this is equal to this. Okay, let's look at number 3. Cosine x times secant x tangent x over tangent x equals cotangent x. Okay, I'm thinking, thinking, okay, I'm going to go with my first goal is to transform the more complicated side of the equation to the simple side. To me, that looks more complicated than that. He said, Mr. Session, well, you can change this and break this down. Remember, you got to pick one side. You can't do two sides. No, one side, okay? Now, I'm going to pick this. So I'm going to come over here, rewrite that to show that I'm going with that side. Now, there is no adding fraction, so no common denominator. I can't factor anything out. No foiling. There's no squares involved with Pythagorean identity. So once again, I'm just expressing things in terms of sine and cosine. Okay, so I got cosine x. And do you see how nice and neat I'm doing this on notebook paper? That's what I need to see on your notebook paper, unless you can do it nice and neat on that worksheet. But if you can't, notebook paper, please. I can rewrite secant as 1 over cosine because of the reciprocal identity, divided by tangent Now, you said, Mr. Session, why didn't you break tangent down? Remember this right here. I want this to be cotangent. Just know, always keep what you're trying to get it to in your mind. Excuse me. Right here, cosine and this cosine can cancel out, leaving me 1 over tangent x. Isn't 1 over tangent x equal to cotangent? Yes. So you just proved that this is equal to this. He said, Mr. Session, I would not have thought about this. I would have done something totally different. Okay? Let me show you another. If you went ahead, you could get the same answer doing this. I will take this. I'm going to come over here to the side and show you another pathway you could have taken. Okay, so watch this. This is another way you could have done this problem. And I would have taken this. Broken this tangent down to sine x over cosine x. You would still cancel those out, and you would have got 1 over sine divided by cosine. Okay, I'm going to come under it and write what it means. 1 divided by sine x over cosine x. Remember, when I divide, I multiply by the reciprocal. Well, 1 times this is cosine x over sine x. Isn't cosine over sine x cotangent? So you just proved that way that cotangent x is equal to cotangent x. I would have taken either way pathways. You could have done this, or you could have went this route. Either way is correct. Either way. Alright, let's look at number 4. Cosine squared theta plus tangent squared theta times cosine squared theta equals 1. Okay. This indeed is more complicated than the 1, so I'm going to go with this side. So I'm going to come under it. And write back to let me know I'm starting with that side. Alright. There's no fraction, so I shouldn't find a common denominator. Then I think about factor. What catches my eye here, you see there's a cosine squared on this term and a cosine squared over here? They both have that in common. I'm going to factor that out. When I factor that out, what's understood in front of this that's left there? 1. Took this cosine squared, it's gone. So I factor the cosine squared out. Once I do that, I look at it and say, something's catching my eye. there's a square in here. Is that a Pythagorean identity? You should be able to recognize that tangent squared theta plus 1 equals secant. So I can put this in place of that. So now I got cosine squared theta times secant squared theta. Okay, remember, I'm trying to get to 1. Okay? I can't break that down anymore, but I can break secant down to 1 over cosine squared theta. This is multiplying, so can I cancel these out? Yes. What am I left with? 1. That is what I wanted. So I've just proved that they are equal. Alright, let's look at number 5. Cotangent theta, parentheses, cotangent theta plus tangent of theta equals cosecant squared theta. I believe this is the more complicated side, the left-handed side. Like I said, right now they're all left-handed, the one's more complicated, but it could be the right-hand side, so don't just get comfortable. You have to look at it. Alright. So I start. I do not have any fractions, so I have in common denominator. Don't have to do that right now. Factoring, I can't factor anything out. Form, I don't have 2 parentheses. Use Pythagorean identities. I don't see a square on the left-hand side, so I'm going to express in terms of sine and cosine. Okay, so cotangent is cosine theta over sine theta. Oh guys, I messed up. I need you to rewrite that so you let me know that that is the side you're working with. Sorry. That's just going to help me when I grade it later on. Alright. Now, so I got cosine theta over sine theta, parentheses, cosine theta over sine theta, plus sine theta over cosine theta. Well, when I do it like that, guys, what happens inside my parentheses, I'm adding 2 fractions. Okay, that means I need to find a common denominator. I got sine and cosine, so my common denominator will be sine theta and cosine theta. Now, cosine theta was missing in the denominator here. Was missing. So if I had to multiply the denominator by cosine theta, I would multiply the top, so it's be cosine squared theta. Here is missing sine, so if I had to multiply the denominator, multiply the numerator. Sine squared theta. So now I'm going to add that. I can't combine that, so I just put cosine squared plus sine squared theta all over sine theta cosine theta. Okay, what stands out to me now, this top part, cosine squared plus sine squared. Remember, there's a Pythagorean identity. Sine squared plus cosine squared equals 1, so you can substitute 1 in for that value. Okay, now we're multiplying. I can cancel out the cosines. I'm left with 1. Now sine times sine is sine squared. Remember, I'm wanting cosecant. I'm wanting somehow to get cosecant squared here. Well, isn't 1 over sine squared equal to cosecant? So I just proved that cosecant squared theta is equal to cosecant squared theta. That is equal to that, and then I just bring this down to show that I proved it. Now that's one way you could do that problem. Now, if you didn't do that way, some of you said, well, I multiply this times this, this time this, and then simplify. Guess what? You could do that in that problem and arrive at an answer that would work, that a pathway that would work. But just remember, when I grade this, I check for each step, because if you do something mathematically illegal, then it won't work. But if everything is mathematically correct and you successfully prove, then I will count it correct. We have two more, but if you need to pause it right now, then please pause it. You've got to learn your trig identities. That's why we're having a memorization test on those Tuesday. That's a 60% chance when this test is Wednesday. Alright, let's look at number 6. Please be using this video to learn, not to straight copy your answers, because that's not going to do you any good. Okay, so I look at number 6. Of course, the left-hand side looks more complicated right there. So I look, there's no fraction, so I don't need to find a common denominator. I can't factor anything out. There's no foiling to be done. They do have squares, but they do not look like any Pythagorean identities. So I'm just going to express it in terms of sine and cosine. So I'm going to come under and write that one to let me know that's the side I'm working with. I'm going to break secant down to 1 over cosine squared. Can't break sine down. 1 times sine is sine squared. Now remember, I'm trying to get to secant squared. Secant squared. That's your goal. I start thinking, okay, there's a Pythagorean identity that says tangent squared plus 1 equals secant squared. Well, isn't that equal to tangent squared sine divided by cosine? So I can rewrite that as 1 plus tangent squared. Well, guys, that's equal to secant squared. You just proved. Bring it down to show. Bring it down. That secant squared is equal to secant squared. And the last one, number 7. Sine theta times secant theta times cotangent theta equals what? Of course, the left-hand side looks more complicated. There's no fraction, so I don't need to find a common denominator. Factoring can be ruled out, and there's no squares. So I'm just going to express everything in terms of sine and cosine. Okay, so I'm going to bring this down to let me know. And guys, if you want to skip lines in between steps, that would help you keep things straight and meet a grade. So sine theta, secant can be rewritten as 1 over cosine because of the reciprocal. Cotangent is cosine over sine, the quotient. I shouldn't have put that 1 there because I'm only working with the left-hand side, so ignore that. Okay, so look at this. Ooh, I love this situation coming up. Everything's multiplying. I could cross my, remember, we're trying to get to 1. Your cosines cancel out. Your sines cancel out. What are you left with? 1. Bingo, that's what you wanted. Bring it down. You just proved 1 equals 1. Well, I hope this helps you guys with your homework. I hope it's a better understanding. Please review. If you need to look at basic trig identities, that's what we talked about today. Pause it if you need to write anything down. And then the verifying, the anchor chart on verifying trig. Your goals and your strategies. Pause if you need it. We will continue this tomorrow. Have a great night. Please make sure you have your homework done.